Hi everyone. Today we are going to be talking about quadratic relations again, and we're going to be talking about the zeros, the y-intercept, the vertex, the direction of opening, and the axis of symmetry. And today we're going to be putting it all together. Also, we're going to be talking about factoring simple trinomials to get our zeros. All right, go ahead, grab your paper and pencil, and let's get started. Okay, so the first thing we're going to talk about is some vocabulary that you'll need to know for moving forward. So the first thing that we need to be able to do is identify the vertex, the zeros, the y-intercept, and then the axis of symmetry. So the vertex, in this particular example, is going to be the lowest point on our parabola. It's basically the point where the parabola starts to change directions. So if you look at your graph, the coordinate 2, -9. So let's go ahead and record that right on here. So the vertex is at 2, -9. So next we're going to look at the zero, or the zeros. So in this case, because our parabola crosses the x-axis in two spots, we actually have two zeros. So if you look at our first point at 8, 0, and the other point is at -4, 0. Remember, the x comes first for the zeros because it's the x-intercept. So let's record those on our sheet. Okay, the next thing we're going to look for is the y-intercept. So where does our parabola cross the y-axis? So if we look carefully at our graph, we can see that the parabola crosses the y-axis at 0, -8. So our y-intercept is at 0, -8. Next, we're going to talk about something called the axis of symmetry. So this is basically where we can cut our parabola in half and have two symmetrical sides to the parabola. And our axis of symmetry cuts right through the vertex. So I'm going to switch colors here. And I'm basically going to just draw a dotted line right down to the vertex, and it's at the line x equals 2. So if you remember from back in grade 9, we talked about horizontal and vertical lines. So lines that are vertical, so going up and down, they have an equation of x equals some number, and horizontal lines have an equation of y equals some number. So our axis of symmetry actually has the equation of x equals some number. And in this case, so our axis of symmetry in this case is x equals 2. We can also label our points right on our parabola as well. So I'm just going to go ahead and do that. Okay, there are the labels right on our parabola. And I've also abbreviated the axis of symmetry AOS. So you will see this abbreviation quite often. So for the axis of symmetry, AOS, axis of symmetry. Okay, let's take a look at our first example here. So Norman collected some data, and it's shown in the chart. So 0, 12, 1, 10, 2, 10, 3, 12, 4, 16, and 5, 22. So the first thing that we're going to do is we're going to plot those coordinates right on the graph. So go ahead and take a minute and please do that. Okay, once you have all of your points plotted, we're going to go ahead and look at our differences on our chart. So we're going to look for our first differences to see if it's linear. And I think by looking at the points that we've plotted, we can see that it's not going to be linear. So then we're going to look at the second differences, or in other words, the pattern within the pattern. Okay, so the first differences, remember, we're looking at the change as we move down the y column. So when we go from 12 to 10, what's the change? And then from 10 to 10, 10 to 12, 12 to 16, and 16 to 22. What are the changes as we move down that column? And remember, you can also get these values by taking the number below and subtracting the number above. Okay, so again, looking at our first differences, those are not all the same going down the column, so know that this is not a linear relation. So let's go ahead and look at our second differences, or in other words, the pattern within the pattern. Okay, looking at our pattern within the pattern, or the second differences, we have the same number going down the entire column. So positive 2, positive 2, positive 2, and so on all the way down. Okay, so part B here says plot the data, add the axis of symmetry. So we've plotted the data already. So we're going to go ahead and add the axis of symmetry. But the only thing is with adding the axis of symmetry, we don't exactly know where the vertex is, what the exact coordinate is, but we do know where it passes through. So our vertex is going to pass through somewhere between 1 and 2. So what's between 1 and 2? Well, 1.5, right? Okay, so let me just go back to our graph here. So I know we're going to have our dashed line at the line x equals 1.5, because 1.5 is between 1 and 2. So let's go ahead and sketch that. So again, that's our axis of symmetry. So I'm going to abbreviate that AOS, and that's at the line x equals 1.5. So next we're going to make a prediction, where do we think the vertex might be? And then we're going to add it to our graph. Okay, so take a minute, think about where the vertex might be, and go ahead and add it to your graph. So I think the vertex might be at 1.5, 9, so that's where I'm going to put mine. Maybe yours will be in a slightly different spot, that's okay. And then go ahead and record your prediction in the line for part C. Okay, the next part, part D, what will the y coordinate be when x is equal to -1? And then we're going to add that to our graph. So let me just go back to our graph. So when x is -1, so we're basically going to look for what's called a symmetrical point. So -1 looks like it's going to be in line with the one that's at the 4. So if I draw in, so that's 2.5, and so on the other side here, 2.5, that will put me at -1. So that's my symmetrical point. So that symmetrical point is at -1 and 16. Okay, so the next part for part E says, what will the y coordinate be when x is equal to -2? And then we're going to add that to the graph. So let's go back to our graph. So -2 is going to be another symmetrical point. So if we look up here at this coordinate up here that's at the 5 and 22, so that's 3.5 on the other side of the axis of symmetry. So if we move 3.5 in the other direction on the axis of symmetry, that puts us at -2. And so that's a symmetrical point. So that's going to be at -2, 22. So again, -2, 22, because that is a symmetrical point. The next thing we're going to do is we are going to make a smooth curve and draw in our parabola. Okay, so we're going to go ahead and draw on a smooth curve and connect our dots. So I like to start at the parabola and draw up in either direction here. Okay, looking at our next example. So a parabola is defined by the equation y equals x plus 5 times x minus 1. So we're going to state the zeros, then we're going to plot the zeros on our grid, and then we're going to add the axis of symmetry. So let's go ahead and do that. So the zeros can be found by looking at our equation. So x equals x plus 5 and x minus 1. So we can think about just switching our signs, or another way to look at this is actually setting each of those brackets equal to 0 and solving for x. So x plus 5 equals 0, and if we solve for x, x equals negative 5. Okay, so we're going to have a 0 at negative 5 and 0. So again, you can see that we've just switched the signs. And the other 0, if we let x minus 1 equal 0, x is going to be positive 1. Okay, so we've plotted the zeros on our grid. Next, we're going to add the axis of symmetry. Okay, so we need to look for the point between negative 5 and 1. So halfway between those 2 points would be negative 2. So that's where we're going to draw in the dotted line for the axis of symmetry. So x equals negative 2 is the axis of symmetry. Next, we need to find the x-coordinate of the vertex. So to do this, we basically take the average of our zeros. So to find the axis of symmetry, the coordinate for the x is going to be negative 5 plus 1 divided by 2. So negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. And that's where we can see that our line is going through our parabola. So sorry, you can hardly see that, but x equals negative 2 is the equation for the axis of symmetry. I also have it already on the grid. Okay, so the next thing we're going to do is we're going to find the y-coordinate of the vertex. And we're going to do this by substituting our answer from part D, so the x value of the vertex, into y equals x plus 5 times x subtract 1. Okay, let's go ahead and do that substitution. Okay, and when we simplify inside the bracket, so negative 3 times 3 is negative 9. So that means the vertex is at negative 2, negative 9. So let's go ahead and record that on our parabola. Okay, part F says add the vertex to your graph. Okay, so we've already done that. Part G, expand and simplify the equation. So we're going to use the box area model and we're going to show our work. Okay, so we have our nice little box here, x and then 5 on one side, and then x and then minus 1 on the other side. So remember, we're going to multiply x times x and we're going to get x squared. X times negative 1 is negative x. X times 5 is 5x. And 5 times negative 1 is negative 5. Then we're going to go ahead and combine our like terms, which are on the diagonal. So we get y equals x squared, and 5x minus x is 4x, and just subtract 5. Okay, so that's part G. H, we're going to state the Y-intercept. So the reason that we actually expanded and simplified in the last example was because we actually need the last digit, so the constant is, so if we go back to the previous example, y equals x squared plus 4x subtract 5. The subtract 5 is where our parabola is going to cross the y-axis, or in other words, that's the y-intercept. So let's go ahead and put our y-intercept on our graph. So the coordinate for the y-intercept is at 0, -5. Okay, so the y-intercept we said was at 0, -5. So go ahead and record that on your sheet. Part I, add the point symmetrical to the y-intercept to your graph, the point that is the same distance on the other side of the axis of symmetry. So we need to draw a point 2 units on the other side of the axis of symmetry across basically from our y-intercept. Okay, the last thing we need to do is draw a smooth curve through our 5 points. So make sure that you extend your parabola all the way to the edge of your grid paper, all the way to the edge of your graph. And then for good communication, I'm going to also write in the actual equation. So y equals x plus 5 times x minus 1. So it's always a good idea for communication to label your graph once you're finished. And also put arrowheads at the end of your parabola to show that we could extend the data further and the parabola. Okay, the next concept that we're going to be talking about is factoring. So we're going to factor each of the following parabolas. So in other words, we're going to try to make it into a rectangle. State the zeros and show your work. Just like when we were looking at our linear patterns, we tried to make things into a rectangle to show that they were quadratic. So we're going to use kind of a similar concept here to show the zeros, basically. Okay, so what we're going to do is we're going to make a kind of table. So on our table, we need to have our x squared plus 7x plus 12. But we can easily put in the x squared and the 12 in our table, but we need to actually figure out 2 numbers that add to give the middle term of 7x, and those same 2 numbers need to multiply to give the 12. So I know I'm going to have an x times an x in order to get an x squared. So on my table, I'm going to put in an x and another x. And then so again, we need to find 2 numbers that multiply to give 12 and add to give 7. So I'm going to just use a little bit of trial and error here. So if I look at 6 and 1, so they add to 7, but 6 times 1 gives us 6 and not 12. So that combination is not going to work. What about 3 and 4? So 3 and 4 add to 7, and 3 times 4 will give us 12. So it looks like that's the combination that we're going to need. So it doesn't matter whether you put the 3 or the 4 underneath the x squared, as long as you have one of each in your table. Okay, so when we multiply, we're going to have x times x is x squared, x times 4 is 4x, x times 3 is 3x, and then 3 times 4 is 12. And if we look at our diagonal, 3x plus 4x is 7. So basically this gives us x squared plus 7x plus 12, which is what we started with, but we're actually looking for the factors on the outside of the rectangle this time. So what we need instead is we need the x plus 4 and the x plus 3, and those are going to give us our zeros. So that gives us x equals -4 and x equals +3, because remember we switch our signs. So again, think about it as if we set each of those factors equal to 0. So x plus 4 equals 0. When we solve for x, we're basically subtracting 4 from both sides. So x equals -4. And the other factor is -3, 0, because if we set x plus 3 equal to 0 and solve for x, we're basically subtracting 3 from both sides, so x is equal to -3. So those are the zeros. So I'm just going to make a little side note here. So we're trying to find two numbers that add to the middle term and multiply to give us the last term. Okay, let's look at another example. So another way that we could set this up instead of using the box method is just like I did here. So blank plus blank equals -2, that's our middle term, and blank times blank equals -8, that's our last term. Okay, so again, if you want to have the little chart to kind of organize your thoughts, go ahead and make your little chart. So I know I'm going to have an x on the outside in order to get my x squared. So I need two numbers that multiply to give -8 and add to give -2. So again, you can try a little bit of trial and error. So if I tried -8 and 1, well, that multiplies to give -8, but it does not add to give -2. So let's try another combination. What if I had 4 and -2? Well, that multiplies to give -8, but 4 and -2 is +2, but I need a -2. So let's try -4 and -2. So -4 and -2, well, that would give me -4x and -2x. So that's not going to work. Okay, so let's try -4 and +2. So -4 plus +2 will give me -2, and -4 times 2 will give me -8. Okay, so this looks like the combination that's going to work. So we have x minus 4 and x plus 2. So again, to find our zeros, we look at the opposite sign inside of our brackets, because if we set each of those brackets equal to 0 and solve for x, we get the opposite. So we have a 0 at 4, 0, and -2, 0. All right, I have one more example. So again, we're going to factor x squared minus 5x plus 4. So we're looking for two numbers that add to give -5 and multiply to give +4. Okay, so if we look at our factors of 4, so 1 and 4 multiply to give 4, but 1 plus 4 gives us +5, but I need -5. So if I look at -1 times -4, I get +4, and -1 plus -4 will give me the -5. So -1, -4, -1, -4. And again, on the perimeter of your box, you can go ahead and add x and then -1, then x minus 4. And so those are the factors. So x minus 1, x minus 4. And so again, if we look at the opposite signs, so we're going to have a factor. So if you look at the opposite signs, we're going to have a 0 at 1, 0, and 4. Okay, so that's everything for today. Thank you very much for your attention. Have a great day. Bye-bye.